Today we will be graphing quadratic functions and also stating whether the graphs open upward or downward. So let's see what these graphs end up looking like. And here are some different functions similar to what you'll see on the handout. And again, the handout is also located on the same website that you're on right now. You just need to look for the copy for handout of graphing quadratics and you'll see it. And so anyhow, we've got y equals x squared minus 3. The first thing I would do is I would set up a table, since we're not sure what these look like. This is the table I would set up. X, and then I'm going to write the function in the middle. So the function is x squared minus 3. The function is what changes the input, which is our x value, that's our input. This function changes that input, and it spits out a y value, which we call our output. So here are the values I would use. -2, -1, 0, 1, and 2. Now I want you to notice something really closely about when we plug in a -2 or a 2 into our equation. You'll end up seeing something that happens that makes the problem a whole lot easier. So let's do these two at the same time. Let's say we had -2 and we square that number. And then we're going to take away 3. Down here, if we square +2, and then we are going to take away 3. Let's see what happens. What is -2 squared? So -2 squared is just 4. So 4 minus 3 is just 1. And over here, 2 squared is 4. Notice that you get the same answer here. For -2 squared and 2 squared, they make the same number. They both make 4. And if you take 3 from 4, we end up with 1. Notice that they're exactly the same. And you'll see that with the next number that we do. See, if you square -1 and you take away 3, you get the same answer as if you square +1 and you take away 3. See, -1 squared is just 1. 1 minus 3 is -2. 1 squared is 1. Minus 3 is -2. So you get the same answer for that. And so no matter what, whenever you square a negative or square a positive, you still get the same number. If we put in 0 for x, it cancels that x squared out. Just got to take 3 from 0, you end up at -3. So now we have some points we can plot. And so when we plot points, they're ordered pairs. And so we start with our x value, we work from the origin. And so we have x is -2. So you go to the left 2 spaces, and then the y value is 1. So you're going to go up 1 space, put a dot there. And for -1, for the x value, go over just 1 space to the left. And then y is -2, so I go down 2. So 1, 2. And then over 0, and then down 3 is the next point. So over 0, so stay right on this y-axis, down 3. And then for this point, over 1, then down 2. So from that origin, over 1, down 2. And the next one, 2, 1. So over 2, up 1. And then we've got 5 points to be able to sketch a curve through. And so you'll notice that this curve ends up being the same as all of the other problems that we do. The only difference is sometimes this is upside down. So it also asks us to tell whether it opens up or down. Well, this one ends up opening up. Opens up. And so it kind of is self-explanatory when it opens in the direction that you're going. So if you're going down, it's closed down here, but it's open up here, so it opens up. And also a few other things to notice about this graph. If you look along this y-axis, this y-axis, if I cut it right along here, I could end up cutting it into 2 equal pieces. So this line here that it goes through, that this bottom point goes to, is called our axis of symmetry. And so what that means is that the points are symmetrical about that axis. So for instance, this point right here is 2 spaces from that axis symmetry. So that tells us that there's a point 2 spaces from this axis symmetry on the other side, and there is. And so once you find these 3 values, and you know what that axis symmetry is, you can plot the other points. Well, let's take a look at our next one here. So we've got a new equation. This one looks a little different because we have a minus sign in front of x squared, and they have a different constant. So we're going to do the same thing. We're going to pick inputs And then we're going to plug them in here. So the opposite of x squared plus 5 is how I'd read that. Now, if I wanted to, I could put a 1 right in between this minus sign, this x, and it's being multiplied by x squared. So whenever you see that minus sign in front of the x squared, think of that as like negative 1 times by x squared. So what we get when we plug in our x values are outputs called y values. We're going to pick the same points, negative 2, negative 1, 0, 1, and 2. And all we do is just substitute those numbers in there. So negative 2 in for x. Now notice we get the same sort of scenario. When you plug in negative 2 for this x and you square it, you get the same answer you do if you put in positive 2. See, negative 1 times by 2 squared. It gives us the same answer. See, 2 squared is 4. Negative 2 squared is 4. 4 times negative 1 makes negative 4, though. Plus 5 gives me 1. Over here, same thing. See, 2 squared is 4 times by negative 1 makes negative 4. Plus 5 makes 1. Well, when we plug in the 1 values, we're going to get the same value. So if you do one of them, you know the other. See, if we have negative 1 times by 1 squared plus 5. You get the same answer if you plug in the other one, negative 1 times negative 1 squared plus 5. You get the same exact answer. See, 1 squared is 1. 1 times negative 1 makes negative 1. Plus 5 makes 4. So we get the same answer over here. Well, when we plug in 0 for x, it cancels out the x term, which we're just left with the constant of 5. So we end up with 5. So from that point, we just plot these points. So 2 spaces to the left means you go up 1 space. 1 space to the left means you go up 4 spaces. No spaces over brings you up 5. And 1 space to the right brings you up 4. 2 spaces to the right brings us up 1. So I just plotted these points. 2, 1, 1, 4, 0, 5, negative 1, 4, negative 2, 1. From there, we sketch this curve. So what's the difference here? Well, the graph kind of looks the same. The difference is that it's upside down. And so we say this one opens down. Now let's take a look at these two since we've done 2 now. What do you think caused this to open down? Well, something in this equation caused it to open down. And so it was this number right here, this minus sign. This minus sign in front of the x squared term forces the parabola down. So this makes it open down, and the reason is that when you square the x value, you end up taking its opposite. So you're always, no matter what, you always get a positive when you square it, but when you multiply by a negative, it forces it down. So let's take a look at the next one. Over here we have a y equals x squared minus 1. So guess which way this one opens. Does it open up or does it open down? Let's see if you're not sure. So we go ahead and substitute some numbers in there. Again, we put the function in place of the middle part. And then we get some outputs. So we have these values, negative 2, negative 1, 0, 1, and 2. And we just plug these numbers in. So when we do that, we have negative 2 squared minus 1. So negative 2 squared just makes a positive. So nothing makes that a negative once you square it. So it's just 4 minus 1, which makes 3. So that tells me that this one's going to be 3 too, because 2 squared minus 1 gives me the same answer. 4 minus 1 is 3. So if we plug in 1 and square it, we have to take away 1 then. We end up with 0. So 1 squared is 1, minus 1 makes 0. Negative 1 squared minus 1 gives us the same exact answer of 0. Well, plug in 0 for x, it cancels it out. 0 minus 1 makes negative 1. So now we've got some points. So 2 spaces left brings us up 3. 1 space left just leaves us right on that x-axis because we go up 0. 0 spaces left or right brings us down 1. And 1 space to the right brings us just right on that x-axis. 2 spaces to the right, 3 spaces up. So notice you get the same shape. Look at where those points are. They're always going to be the same when it's x squared, no matter what. No matter where this equation is, you're always going to have this bottom point. This bottom point, some more terminology here, this is called the vertex. So you're always going to have these 3 points with an x squared, or even a negative x squared. It's just going to be going the other direction. These 3 points that kind of make a triangle right here. And then these 2 points here. And they're always going to be the same distance from this vertex. See, 2 spaces to the left or right, 4 spaces up to get to those 2 points. It's the same thing over here. You see 2 spaces left or right, we go 4 spaces up, we've got those 2 points. So we say this one opens up. And what caused it to open up? Well, it's that number out in front of x squared. It's a positive x squared. So when it's positive x squared, it opens up. Well, one more to try here. Let's take a look at this one. We have our x values. We've got our function, and let's put in negative 1 times by x squared plus 2. And then we get our outputs. And we'll do the same thing. Pick some values, negative 2, negative 1, 0, 1, and 2. Let's try doing this a little quicker this time by looking at that concept of similar numbers. So when we go ahead and plug in a negative 2, and we square that, we end up with a 4. 4 times by negative 1 makes negative 4, and then we have to add the 2, and that gives me negative 2. So that tells me that 2 is going to also be negative 2, because negative 1 times by 2 squared is, 2 squared is 4, times negative 1 is negative 4, plus 2 makes negative 2. So we get the same thing with 1. Negative 1 times by 1 squared plus 2, that makes 1 times by negative 1 makes negative 1 plus 2 makes 1. So we know this one's 1 as well. Well, 0 plus 2 just gives me 2. So now I've got some points to plot. So over 0 up 2. Over to the negative 1 we go up 1. To the positive 1 we go up 1. To the negative 2 we go down 2. To the positive 2, down 2. And then from there we've got our graph. So what forced it to open down? Well, it was this negative sign here. So that minus sign right there made it open down. And so there we have it. Some problems that you'll see on tonight's homework. Well, good luck.